Hi, so this is the second video in the defining rational expressions section. I'm going to call it simplifying expressions. That is not what the section is called, but it's part of this section. We define them and then we simplify them. So we're going to simplify a rational expression. You can also call it reducing a rational expression the same way we reduced a regular fraction. So this is not in the notes, but just to bring you back to how we reduce a fraction, if we wanted to reduce 6 over 24, for instance, well, what we would do is figure out all their factors and reduce out the ones they have in common. So 6 is 3 times 2. And 24, we have to dig a little bit deeper. But if you get way down to the factors that cannot be broken down any further, 24 is 3 times 2 times 2 times 2. And so this is the same thing we're going to do with these rational expressions. We're going to figure out all of their common factors and then take them away as they match. So we see we have a 3 in the numerator and the denominator, so those reduce out. We see that we have a 2, 1 2 in the numerator, so it can go with 1 2 in the denominator. So everything in the numerator is gone, which, remember, doesn't leave us with 0, leaves us with 1. And then we have whatever's left down here, a 4. Okay, and so that's how we're going to reduce rational expressions. We're going to find their factors, which we know how to do because we can factor polynomials, and then whichever factors match are going to be reduced out. So let's look at simplifying some of these expressions. We'll start with this one. Now, just looking at it, let's remember things we're not allowed to do. Only things that can be factored out can be reduced out, or as we sometimes say, canceled out. So for instance, these x's right here, they're not factors of everything in the numerator and everything in the denominator. So even though we see them in both places, that doesn't mean we're allowed to reduce them. If you can't factor it, you can't reduce it. So our job is to figure out factors. So let's look at factoring the numerator. It's only got 2 terms, so we can try a greatest common factor. So they each contain a factor of 4. And what we have left over is an x and a minus 2. And we look, and I can't factor anything else out. You can factor the 4 out to look like 2 times 2 if you want, but we'll do that if we have to. Let's look at the denominator. Again, a binomial, only 2 terms. Let's look at what they have in common. Each one contains a factor of 3. And if we look at what's left over, we have an x and a minus 2. Again, we look, this is completely factored. There's nothing else we can factor. We can't break it down into factors any further. So we're done factoring numerator and denominator, just like we were factoring out the 6 and the 24. So now we look for places where we see matching factors. So 4 and 3 are both, well, 4 is not a prime, but 3 is a prime. 4 and 3 don't share any factors, but we do see both numerator and denominator share this factor of x minus 2. And that's the situation you're allowed to reduce. These x's could not go away, but x minus 2 is a factor of both, so they can go away. And our simplified expression is 4 over 3. Now, this doesn't really have anything to do with like the restrictions going away. There are still restrictions on this expression, but it does simplify down pretty nicely. Okay, let's look at some more. Now, what you'll notice is that the factoring might get a little more complicated, but the process is always going to be identical. We're going to factor the numerator, factor the denominator, look for some common factors. Okay, B kind of shows you something that could happen to look out for. Okay, so let's look at B. If I look at the numerator here, 9 and minus x do not have any obvious factors in common. I don't have a greatest common factor for those that come to mind. So for now, let's just leave it like it is. It doesn't factor in any way that seems helpful yet. So now let's look at the denominator. It's a binomial. Each one of them contains a factor of 5. You're hearing Kevin the new dog, if you can hear a dog barking. So they each contain a factor of 5. And what's left over is x minus 9. And we look at these two, and 5 is a prime number, so there's no way it has any more factors. Neither does this piece. So it doesn't look like we have any common factors here, because this is a 9 minus x and this is an x minus 9, and they are not exactly the same. However, if you notice, we have a 9 minus x and a minus 9 and a plus x down here. So these are almost the same, but every sign is different. If ever that happens, remember what you're always allowed to do. You are always allowed to factor out a 1, and you are always allowed to factor out a negative 1. So notice if we factor out a negative 1 from the numerator, if we do 9 divided by negative 1, we get negative 9. And if we take this negative away from the minus x, we're left with the plus x. So notice we factored out a negative 1, and all it did was change the signs of these two pieces, which makes it match exactly with what's in the denominator. Okay, so even though they're not in the same order, this has an x and a minus 9, this has an x and a minus 9. They match. So they're able to reduce out. And we're left with a minus 1 over 5 as our completely reduced expression. So always keep this in mind. It's not obviously necessary until you get to a point where you see it is necessary. Really, that was here, where we see that the terms are exactly the same except for the signs. If that's ever the case, try to factor out a negative 1. If they match, cancel them out. Alrighty, now let's look at another one. And this is one where the factoring gets a bit more complicated. Okay, so first of all, we see this 2 in front of the x squared, and usually that means this is going to be a hard problem. But look at all the terms. 2, 12, 18, we have a greatest common factor. So we could take out a 2, and that would leave us with x squared plus 6x plus 9. So we may be able to do something extra with this, but we'll get to it in the next step. We see in the denominator, this is a difference of squares. We have x squared minus 3 squared, right? So this is going to factor as x plus 3 times x minus 3. Okay, so looking at it, we don't see anything in common yet, but remember this part's not finished. So let's finish factoring that part. The 2 still stays there. That has a leading coefficient of 1. So we know what our factors are going to look like. X and a number, x and a number. We already know what the denominator looks like, so we'll go ahead and write that. Okay, so now let's look at what those numbers have to be. So we have a product of positive 9, so we know the two numbers have to be the same sign, and a sum of positive 6, so they both have to be positive. Well, it's pretty quick here. 9 doesn't have very many factors. We're looking at plus 3 and plus 3. All right, so now everything's all factored out. Everything's out in the open. We can see if there are any common factors. And we can see this one has 2 factors of x plus 3. This one has 1. So we can pair up one pair of them, and they can go. So now we write what we're left with, and that's going to be our simplified expression. We have a 2 and an x plus 3 left in the numerator, x minus 3 left in the denominator. And that is the simplified expression, 2 times x plus 3 over x minus 3. Since this is the only thing in the denominator now, I dropped the parentheses, but you're welcome to keep them there if you want to. Okay, so again, it all comes down to factoring and dividing out what's common. We'll look at how many more of these? 2 more? Okay, let's look at D. D, we've got x squared minus 2x minus 3 over x squared minus 6x plus 9. All right, so we have 2 trinomials, each one with a leading coefficient of 1, which is good news for us because we know it's going to be a little bit simpler to factor. We know that all the factors in this case, numerator and denominator, are going to start with an x and just have another number in parentheses. So in the numerator, we need two factors of -3 that add to -2. So we know these have to have an opposite sign or opposite signs, and the bigger number has to be negative. So it doesn't give us much of a choice. -3 and +1 it is. Yeah, that's the only way that's going to happen. All right, denominator. We need two factors of 9 that add to -6. So they have to have the same sign because the product's positive, and the sum is negative, so they have to both be negative. So once again, we don't have much of a choice. Both of those numbers are -3. Now we look for common factors. Each piece has one x minus 3, so they can go. And we're left with x plus 1 over x minus 3 as our simplified expression. Okay, let's look at one more. This is really just one to look out for. It's a really easy problem if you know what kind of answers you're allowed to get. So this one is 3x plus 4 over 4x squared plus 9. Okay, let's start trying to factor. So in the numerator, we have just a binomial. So we first try to look for a greatest common factor. We have 3 and 4. No luck. And this is not a difference of squares. So this thing doesn't factor. It's just going to have to stay 3x plus 4. Denominator. Once again, we look for greatest common factor. We have 4 and 9. No common factors. It almost looks like a difference of squares, except that this is a plus. So it's not even a difference of squares, it's a sum of squares. So once again, we're out of luck. We end up just writing the same thing over again. Nothing factored. We don't have any common factors on top and bottom. That's it. This thing was already simplified. So that is a possibility. If the numerator and denominator don't factor, or if they do factor but you can't find anything that is common on numerator and denominator, you can't do anything. Already simplified. So that is a possibility. Don't worry if that happens. You're probably correct. If you have a question though, let me know.